Hi friends, this video we are going to talk about change of basis. First we start with the definition of transition matrix. The matrix representation of ID alpha to beta. So this is a matrix of identity transformation ID from vector space to vector space V with respect to any two bases alpha and beta is called the transition matrix or coordinate change matrix from alpha to beta. Okay, what I think, so they are telling that, so ID alpha beta is a one matrix, correct? It's a matrix representation of identity transformation they given. So what is the alpha? Alpha is a one basis of V and beta is a another basis of V. Okay, so suppose I take it as alpha equal to one basis we call it as a U1, U2, UN. Okay. Similarly, I have the another basis I taken as a namely beta. The bases are 1, V1, V2 and so on, Vn. So we have the two bases. So what I define this, the matrix representation, what is the ID alpha means? I of U1, we get the U1 only, correct? I can represent U1 in terms of the basis V1 because this U1 belongs to V. I can represent beta in terms of beta. So I can represent any linear transformation into a matrix representation I can represent, correct? So I want to represent ID alpha to beta. So this is nothing but it is a matrix of the first column is ID of U1 their coordinate vector. That is our first column. What is the second column? ID of U2 in the second column and so on. ID of un beta. So this is the some matrix representation we will give. This matrix we call as a transition matrix or coordinate change matrix from alpha to beta. The reason is why they called it as, suppose I taken as ID alpha to beta. Okay, suppose I have the one vector x belongs to V. The coordinate vector in alpha is we called as a x alpha. It gives directly we get it as coordinate vector of x beta. That is why this matrix we called as a coordinate change matrix from alpha to beta. Suppose you know what is the coordinate vector of the x in alpha, you can get it in the coordinate in the beta, simply the matrix multiplication. You clear wherever the downsides, the alpha means your input basis, beta means your output basis. That's it. That's why we have denoted ID alpha to beta. Similarly, you can find ID beta to alpha times x beta equal to x alpha. This way also we can represent. Yes. Now we see few example to understand what is the matrix representation of identity transformation. That is our transition matrix and coordinate change matrix. The first example, so very simple example only we take it. Example 1. Consider the following two bases of R2 namely alpha equal to 1, 2, 1, 3, 5 and beta is 1, minus 1, 1, minus 2. The question is find change of basis coordinates, find the transition matrix. From alpha to beta, and second we want to find the transition matrix from beta to alpha. So why I remove the change of basis? Which change of basis I will come little later. So they given the two bases, one vector space R2 they given. Now I am going to solve. So I start with the solution in the new page. So what is the alpha is? The given is alpha equal to 1, 2, 3, 5 and beta is 1, minus 1, 1 comma minus 2. Okay. Now I want to define one identity transformation from V to V. So here the basis is alpha, here the basis is beta. I want to represent in terms of the matrix representation, that is my transition matrix. So what is the ID of this element is I taken as U1, this is as I taken as a U2, this guy is I taken as V1, this guy is I took as V2. So I of V1, I of U1, I of U1 is again U1 only will come, that is U1, that is 1 comma 2. So first step is I want to A11 times V1, because my codomain the basis is beta. So I can represent in terms of V1 plus A21 times V2. So this implies 1 comma 2 equal to A11 times 1 comma minus 1 plus A21 times 1 comma minus 2. So this guys become system of two equations will come, that is A11 plus A21 equal to 1 minus A11 minus 2A21 equal to 2. You will get it correct. Now this equation we have simply added. So remaining the first part, so you will get it as this implies, suppose you take this is equation number A, this is equation B. So A plus B, we got minus A21 equal to 3. This implies A21 equal to minus 3. If you know the A21, I apply in the equation number A, I will get A11 equal to 4. So I of U1, their quantity vector is 4 minus 3. Similarly, I want to evaluate what is the I of U2 coordinate vector. So I of U2 is, I of U2 value is 3 comma 5. So that is equal to U2, U2 is 3 comma 5. So here I want to find it as A12 times V1 times A22 times V2. Here V1, V2 is the vector, A1, A2 is the scalar. So this implies 3 comma 5. V1 is we already given is A12 1 comma minus 1. V2 is 1 comma minus 2. So 1 comma minus 1 plus A22 times 1 comma minus 2. So this implies I will get the system of equation A12 plus A22 equal to 3 minus A12 minus 2A2. I will get it as 5. Similarly, this is the I taken as the equation C, this is equation D. So C plus D, as because our coefficient matrix is always same in the both cases, that's why I do the similar arguments. So I will get, if I add that, so I will get that minus A22 equal to 8. This implies A22 is minus 6. Once you know what is A22, you apply in the equation number C, you will get it is A12 is 11. So I of u2 beta. That is coordinate vector of I of u2 is 11 and 8. So my transition matrix means the column wise I want to represent as the coordinate vector. Okay, right? So ID of alpha to beta is 4. First column is 4 minus 3. Second one is 11, 8. This is the transition matrix from alpha to beta. So that's why our first question is over, because find the transition matrix from alpha to beta. Second problem is I want to solve transition matrix from beta to alpha. So here the same idea we are going to use it. ID beta to alpha, that is I want to find. What is means your domain is V1, their coordinate vector of alpha you want to represent, I of V2, the coordinate vector of alpha. So what is the V1? V1 is 1 comma minus 1, V2 is 1 comma minus 2. So I of V1 1 comma minus 1 equal to A. So I have already used the matrix A. So for the time being I will take the B 1 1 times U1 plus B 2 1 times U2. So 1 comma minus 1. What is U1? U1 I already taken as 1 comma 2. B of 2 1. U2 is 3 comma 5. So you represent by the system of equation B11 plus 3B21 equal to 1. 2 times B11 plus 5B21 equal to minus. So this equation we want to solve it. This is system of equation, I have to solve it. So this equation I taken as so D already used. So E, the second one is I taken as F. So the E equation is multiplied by 2 minus 2. What will happen? Minus 2B11 minus 6B21 will get as minus 2. Correct? Now we add this equation, you take as G. If you add together the F and G, you will get the 2B1, 2B will cancel out. This guy is become minus B21 equal to, just you add it only, so minus 3. So B21 equal to plus 3. My next step is I want to, once you know that what is the B21, you want to apply here. So B11 plus 9 equal to 1. This implies B11 equal to minus 8. So I of V1, their coordinate in terms of alpha is minus 8, 3. Similarly, we have to evaluate what is the I of V2. So I of V2 is 1 comma minus 2. So 1 comma minus 2 is equal to B12 times 1 comma 2, that is my V1, U1, B of 2 is 3 comma 5. So same the coefficient matrix only will going to come again. So B12 plus 3 times B22 equal to 1 and 2 times B12 plus 5 times B22 equal to minus 2. The same way you multiply, this is you take H, this is you taken as I. So multiply the I by 2, H by minus 2, multiply H by equation by minus 2, it implies minus T2B12 minus 6B22 equal to minus 2. If you are going to add together, what will get it? You will get it as, this guy will cancel out. So minus B22 equal to minus 4. This implies B22 equal to 4. Once you know what is the B22 is 4, then you apply in the H equation, B12 equal to 3 times 4 is 12, 12 plus 12, this guy means you take minus 11, you will get it. So now you taken as I of V2 alpha is nothing but you will get it as minus 11 and plus 4. So I require the ID beta 2 alpha. So that is matrix representation of beta 2 alpha equal to I of V1 alpha. I of V1 alpha is minus 8, this one, minus 8, 3, this matrix, correct? This column. So minus 8, 3. Second one is IV2 alpha is minus 11, 4. This is the transition matrix from beta to alpha. So we complete these two cases. Now you look. So ID alpha beta is 4, 1, 4, minus 3, 11, 8. ID beta 2 alpha is minus 8, 3, minus 11, 4. So you can see any relation, that is the key. So if you look, what is the determinant of this matrix is? Determinant of matrix is 1, you will get it, correct? Determinant of ID alpha beta. Alpha to beta. So what is the determinant? So what is the ID alpha is? So that is determinant of 4, 11, minus 3, minus 8, correct? So what is the determinant is? Determinant is 1. Similarly, this way, determinant of ID beta to alpha, that is determinant of minus 8, minus 11, 3, 4. You will also get here also 1. Then further, then you take the adjoint of ID alpha. So classical adjoint matrix. ID alpha to beta is, first step you are interchanging the main diagonal, that is minus 8, 4, then multiply the minus 1 in the this diagonals, okay, minus 11 and 3. So what is the ID alpha to beta, the whole inverse equal to 1 over id determinant of id alpha to beta times adjoint of id alpha beta. Correct? So this is nothing but determinant of this value is we get 1. So adjoint of is minus 8 minus 11, 3, 4. So this is nothing but id beta to alpha. You please check this is coincide or it's always true. It is always true. That is only we derive the conclusion. Okay. Because when you are changing the basis from alpha to beta, then beta to alpha is always inverted. See. Okay. That is why some texts they refer id alpha to beta is the, so this is I consider as a remark or definition, whatever you take it as. Okay. Remark. No, I take this as a definition. Okay. id alpha to beta is the change of basis matrix from beta to alpha. So please clear, the change of basis means it is beta to alpha only we are taking. The coordinate change means we are taking alpha to beta. That is why we want to please clear with the definition. Okay. Change of basis matrix means your input is alpha to beta, but you write it as beta to alpha. This is a we consider definition of change of basis. I hope you understand what is the concept of transition matching or coordinate change matrix, and finally we conclude the change of basis matrix. Thank you for watching this video.